Okay, guys, so I think we can start. Like, I cannot see any other joining us. Eventually, they will be late. First of all, it's recording, so you can later on refer to this lecture. Also, you can refer to the one that was previously about the networking, the low-level protocols. So today we go into the application level protocols, which is perhaps from the user's point of view a little bit more important. I mean, you as a developers will mostly focus on this part of implementation. If you are more on creating a whole network from scratch, then please refer to this previous lecture because that will help you a lot. Well, definitely you should. I will just want to introduce two high-level protocols for you. One of those protocols is called MQTT. Perhaps you have heard about it. I just wonder if you know, but is it like many of you are using Facebook Messenger, isn't it? Who is using a Facebook Messenger? Which one of you?
I think all of us.
Most of you, isn't it? Yeah. Okay. Interestingly, I can tell you that at the very beginning, when Facebook started to implement it, this was the first protocol of choice. Yeah, we can hear you. Yeah, we can hear pretty well. That was the first protocol of choice. So the Facebook Messenger, actually, it still works on kind of the clone of MQTT. Of course, it was optimized, extended a little, but that may be like a large-scale example that this approach really works. Of course, regarding IoT, it's a little bit different. We use it a little bit different way. However, the principles are the same. So this is one of the protocols. The second protocol is COAP. It's somehow opposite to the MQTT. I will just show you both approaches. There are, of course, many other protocols, but those are the two most prominent and easiest to implement. You will use MQTT in your laboratory work. So that's coming, and I will explain you how to approach labs next week. I just today agreed with Agris how we are going to organize this in this new situation with COVID. So you will work on the remote laboratory notes, perhaps. So what I just want to tell you is that generally, perhaps many of you have noticed that the most popular protocol, communication protocol, this high-level application level protocol, in the internet, it is HTTP, isn't it? I mean, you use it daily. I mean, even right now, when you connect to this lecture, you type it something like an HTTP and then the address and all the stuff. So all the internet is based on that, isn't it? Anyway, it's very heavy. Perhaps you're not web developers, but the thing you can really do, even right now, you can click in your browser on the keyboard F12, and then you will have a source code for your web page. Then if you go into the network section, or like it's showing you the transfers for the network, you will see how many information at the moment your browser is exchanging forward and back. So just to be clear, just the header of the HTTP request you send from your browser, the plain one, just you type very dummy web page that doesn't contain any special stuff. It's like a 24 plus 8 plus 8 plus 31 bytes without payload. This is like a minimum. Now, the browsers used to add information about the cookies you have and information about the type of the browser, many other things. So that's really heavy protocol. It's not very lightweight. Well, no surprise. If you consider what is the payload in your operating system, whatever you are using, whether it's Linux, Mac OS, or Windows, the browsers used to take a lot, isn't it? They take a lot of memory and they transfer most of the data that goes through your browser. So the problem is that HTTP is like when you request some server, the server have to be in the public space. You cannot go through the firewall in opposite direction, right? I mean, actually, firewall was invented just not to let you go in opposite direction, right? It blocks communication from outside to your computer. But now in IoT, it's opposite. Your device, which is at the very end, is something that serves the data, isn't it? It just measures some phenomena and it serves some data. On the other way, if you have an actuator, perhaps you need to access this device to tell what to do. So it is opposite to what you do when you browse the web. I mean, here, web wants to browse you, not you browse the web. So crossing the firewall boundaries is a little bit problematic here. Now, most of you are at the moment connected to some routed network. I guess maybe some of you are on the GSM communication, but many of you are connected over the Wi-Fi to your access point, right? And you are perhaps in the private network. Your private network goes over network address translator. It's a bit problematic because from the outer point of view, again, all the addresses hidden behind your network address translator, also behind the router, they're like a single device. You can recognize them externally. Of course, as I was explaining this previous lecture, you can use port mapping, port addressing, but that's very complex. If you implement an IoT network this way, it's not going to work in the mass scale, sorry. So at some moment of time, HTTP protocol was carrying mostly HTML. So the web pages are in HTML mostly, isn't it? Actually, it's a kind of the clone of XML right now. What is the slight difference in HTTP was born much earlier than XML protocol. And XML is like a structured one. So you always open the tag and you always need to close the tag. In HTML, there wasn't this need. Unless there's a merging of two of them called XHTML, which actually most of the web pages at the moment, there are this compatibility with XML for parsing the data. So you can still like extract the data using XML parsers, even if you download the HTML page, if it is correctly constructed. Browsers sometimes struggle to render it correctly if there's something wrong with that. But they have much more tolerance. So, for example, they do not check very carefully of closing the tags like break tag or div or whatever else. But from the XML point of view, you need to close the tag. Otherwise, the file is invalid. So again, there is a huge overload over the information you carry. I would say in most of the HTML and HTML pages, 50 or 60% are just the tags that telling you how it should look like, and just 50 or 40% is content. In IoT, we cannot afford that. That have to be simplified. So let's go into the details. Because MQTT comes from the Message Queue Telemetry Transportation Protocol. It was invented by IBM, if I can remember correctly, a time ago. The standard is open. Right now it's version 3.2, so it develops a little, but you can consider it like a constant. So it means that if you use any library at the moment available on the market and you implement it in the IoT system, that should be backwards compatible, so your system should be safe for something like a dozen of years starting from now. Considering to the ISO OC protocol stack, MQTT covers 5 to 7. So it's application, presentation, and session layer. This protocol is really simple and lightweight. It crosses the boundaries like firewalls, NATs, and all this stuff. And it's designed for constrained devices. Like, for example, your end node devices, when they constraint is about the memory, about the CPU, but also about the power, which is actually nowadays is the biggest problem, just lack of the power. I can put it with some solar panel far away, or just the battery power it, and you want to let it work for a year for a single charge. So that's it. Now, it is also designed for the low bandwidth connectivity, which is mostly the case of, for example, LoRa communication. It works with unreliable and high latency networks, which is also the case considering, for example, you have a mesh network like presented previously a week ago, and it goes over a number of hops between the data producer and the edge router. That's considered to be a high latency network then. MQTT uses something like a public subscribe. So what it means is pretty close to a single transaction you do when you open the web page. You send the request and you get the response. But there's slightly different because the network communication is totally different. It's coming in a minute, so I will explain to you using some pictures. A couple of more properties. You can have an ensured reliability, which is not the case in HTTP. So here, embedded into the protocol, it's an information on how to ensure the reliability and the quality of the service. For example, if the message was delivered for sure, you can have this mechanism here just to be absolutely sure that the sender and the receiver get the message correct way. In case of the HTTP, there's mostly none. You need to use some other special systems like tracing of the cookies, but it's not embedded into the protocol natively. Here it is. MQTT, which is actually perhaps the biggest drawback, is used for the TCP networks. For the TCP networks, this means you need to have an open connection between your MQTT client. Don't think about it like a client is, for example, the data consumer. No, not the case. It's just like opening a pipe to the server. So you need to have a constant connection between the client and the broker. There is a version called MQTT-SN, which is implemented for non-TCP networks. For example, 4.6-LoWPAN, which is a datagram-based one, like an UDP. But we will mostly focus on this first version. This protocol in the standard version is for the regular TCP networks. So we are going to work with this one. Now, how it works? Okay, so what is the publish-subscribe approach here? Every single device can be a data publisher, so you just emit the data, or a data subscriber. So subscriber is someone who waits for the data and processes them. The devices can interact like both. So not only just a publisher or just a subscriber, but you can be both. I mean, in most cases, you're both. You publish some data, but you also consume some data. Consuming data is not necessarily related to the actuators connected. It can be, for example, achieving some information to, example, present some information like, could you please send the temperature in centigrades instead of Fahrenheit or opposite, right? So it can be the configuration. It can be like a firmware upload to the device also. It used to happen over MQTT and many others. So a device can be the publisher, the subscriber of both. Now, what is the broker? The broker is a center point. You can think about this like a server. It is really lightweight. I used to implement it using Raspberry Pi, and even Raspberry Pi, this first generation, can handle that. So for a simple scenarios like a smart home, a device, low power, fog class device like Raspberry Pi is really good for that. Of course, you can have, and there are many open MQTT brokers in the web. Some of them are pretty loaded, and they are implemented like virtual machines in the hosting centers. The problem is that if many people use them at once, you may experience some slowdowns and the delays between the delivery between the publisher and subscriber. So for our labs, we'll use a dedicated one, which is set up at our university. We'll connect over internet, so I will show you and tell you how it works. Now, regarding the broker must be present in the public addressing space. Of course, you have a local solution, that's okay. You can keep it in the single network, which is, for example, separated from the internet or it's behind your NAT. But then you won't be able to reach it from the external. So it's good to have a broker in the public space. Why? Because then you can integrate it easily with cloud solutions. So the cloud can be a publisher and subscriber to your broker. And for example, you can use a Google Cloud or IBM Watson or Amazon or even Microsoft Azure, which also natively provides connectors for MQTT. You can just connect them to your broker. So it's good to have a broker in the public address space so everyone can reach it. Now, um, this is the structure where the broker is a center point. So it means that if the broker is down or your network is down, this is the serious disadvantage here. There is no distributed communication. Well, indeed, it's centralized communication. It's in the critical system. It's used to be implemented with redundant and load balancing, but it's always like a single stuff in the center here. So your broker is like a very important part of this game. If it doesn't work, then all your network is down. Now, in this context, broker is a point where all the messages they go through. So broker has information about the devices that are connected to it, and also about the subscribers. Well, subscribers, they subscribe to the data. So they tell the broker, if some particular kind of data comes, I want to hear about it. I didn't tell you it yet, but MQTT message itself is composed of two parts, a topic and a payload. And the subscription is just by the topic. So for example, you subscribe to some particular topic that has been published by some other device or some other devices, and then you will be notified whenever this device sends a message. All subscribers will receive a notification from the broker and will receive this data. The broker is responsible for providing this quality of service. So, for example, to have this ensured delivery. And the broker can also retain messages. The retaining message is a technique where you store some information. And for example, your publisher goes to sleep, but it sends like a last information. Last information, for example, could be a temperature measured once an hour. So we provide it into the broker. Broker makes a copy of that and keeping this. And now, when asynchronously any subscriber connects to, it not necessarily needs to wake up the publisher to receive the data. It just gets a copy from the broker. So this is the message retaining. Interestingly, if you relate it into the MQTT, and related to the Facebook Messenger, data retaining is, for example, your status. Sometimes you disconnect from Messenger, and first of all, the guys, they can see last information that you have sent, so the history. And the second is, for example, they can see some particular status of yours, right? So you just went to be disconnected, but you keep some message, for example, we'll be back in 5 minutes or whatever it is. So this is message retaining here. Yep. So each subscriber, when subscribes, it automatically receives the last value for this particular. It's identified by the topic, same like a special kind of the topic. So you can consider it like a state, for example. And the broker generally relays the content from publishers to those subscribers that are interested in. Okay, so now is the question, how do you actually subscribe to some particular message? Now here's an answer. It's based on the topic. MQTT is text-based, so it's data agnostic. And the message is organized in the form of the, you can consider it like a directory structure. We use a slash as a delimiter, like this forward slash, like in the Unix or Mac OS. And hash stands for the entire branch, while plus stands for the single level. It's like a placeholder. So whenever you subscribe, you can subscribe to some particular message. Like, for example, here you have PolySL, AEI, room, sensor, temperature. So this is a subscription for this particular topic. And whenever this topic has been published by any of the publishers, the subscribers will be notified with this topic and the payload. While in case of something like below, you can use a wildcard to subscribe. So for example, this plus stands for any room, any section here, right? But it means just a one section, while this hash stands for anything else that comes. So for example, hash could be a temperature, but could be like a temperature slash thermometer 1 slash device 3, for example, as well, right? So you can use like a wildcards here. It's pretty similar when you type in looking for the files like a star. Star in the file system stands for anything, right? While a question mark stands for the single character. So here, plus is for a single branch, like between one slash and the other slash, and the hash is for anything else. So generally, if you subscribe for hash itself, you will receive all the messages. Just for those who want to experiment with that, it's not a good idea because the broker also contains a ton of the messages generated internally to let someone externally monitor the state of the broker. If you subscribe to hash, you will have 1,000 of messages every second, and that's going to be crazy. So always use some determined part, right? Some information you want to subscribe to. And now it's state of the art to design a good topics because you need to foresee your structure, but also to be open for future extensions, of course, if you expect it to happen. So be careful about that. Quality of service in case of the MQTT is on the 3 levels. First is an unacknowledged service. So it is delivered at most once to each subscriber. Actually, you just publish a message, you forget about that, and the broker forwards the message to the subscribers, those that have subscribed to this particular message, and that's all. No acknowledge, no recovery, just a very basic service. Well, in a reliable network, it's enough. If you consider, for example, a Wi-Fi, that's pretty enough. But if your network is a little bit more complex or is unreliable, then you should go into this acknowledged service or assured service. Acknowledged service is it ensures that the deliverer of the message at least once. So it can happen that the broker can retransmit the message. The broker expects acknowledge, otherwise it makes retransmissions. And assured service is like a 2-step delivery. So first, it ensures message is delivered exactly once to every subscriber. So this is like a highest quality service. Of course, it costs time. This one and that one, they cost the time. They need to wait for the acknowledgements. So we usually in the laboratories where you have a pretty good network, you will use this first unacknowledged service level. But you can experiment with those two. It's pretty okay. Note, not every broker implements these 2 quality of services. You can find the brokers, well, the most popular is Mosquito. It implements pretty good them, but they are like a lightweight brokers, and particularly the open source ones, and they not necessarily provide those 2. So sometimes you may be unable to use them, but the first one is always like a standard. There is a clean session flag also. It's for durable connections. What I mean here is if this clean session flag is set for true, then the broker removes all the client subscriptions on client disconnect. What I mean here is when you write it later on in your software, at some moment of time you connect to the broker, and some moment of time you disconnect from the broker. It's good to clean after yourself when you leave. Because if you keep it false, this connection remains somehow idle, and all the messages are collected and delivered once the connection is back. So you will have like a garbage when you reconnect to the broker. It's also important in case of the following scenario. Imagine, for example, that as a Lima here, right? So imagine that Lima writes an application. And every client needs to have a unique name. So you, for example, provide your name Lima. When someone else, for example, Maris, wants to use Lima's code for another device, then perhaps you will also connect with this client name Lima because you forgot to change it. And you will have a glitch here because that will be the different client that hits actually for the first time broker, but the broker is absolutely sure that it has already seen this client because it's based on the name, not, for example, the MAC address or IP address. It's just based on the name. So if you don't use a unique name and you don't use a clear session flag, then you may have unforeseen problems when connecting back to this with the other client. So be careful about that one. If something bad happens, that means perhaps you're using the name that was already been used by some other client, which is non-unique. And also, this client didn't make a session flag true when connecting and disconnecting. So there is some garbage left. Now, there is a great thing called MQTT wheel. And this MQTT wheel is actually a feature that will enable you to notify someone, I mean subscriber, that something bad has happened to the publisher. It's also working for the subscribers. So any client connecting to the MQTT broker can set an MQTT wheel. This wheel is like a message that will be broadcasted if the broker loses the connection with the client, whichever way it works, publisher and subscriber, both. It loses the connection to the client, but uncontrolled way. For example, the power is down or the network is broken suddenly. So you didn't have an opportunity to legally disconnect from the broker to tell it, okay, I'm disconnecting and thank you for your service. If you just break a connection in the middle of nowhere, then after some timeout, the broker will issue this MQTT wheel to all the subscribers that are subscribed for that one. This is really great because you can identify this way that your network is down or your devices are down, or it's pretty good for the security system. If someone breaks, for example, switches off the device, you'll have an instant notification and the alarm can be raised automatically. Now, security. Okay, that's weak. Security is like a drawback here. All we can have is like a plain text user and the password. Of course, you can transmit it over secure channel. So there's MQTT-S, so you can use this SSL and the TLS. Most of the brokers, they also provide right now an extension that lets you connect to it using a certificate, the public key for the encryption. So we need to first to pull the public key to encrypt the data, and then you can connect to it using public key. But generally, there is no a very sophisticated user and the password authentication. This is like a very basic and the plain one like we used to have in early internet. You just type it in the form, your name, your password, and that was transmitted over the web without any handshaking, TLS, dynamic key exchange, all this stuff. So that's considered to be drawback. But anyway, still, if you use your user and the password and transmit it over an encrypted channel, like for example SSL communication on TLS, that's relatively safe. This is the way you log into your banking system, right? You also type your first and the name, last name, or just email address and password, and that's been transmitted to the server, but over a secure connection. So if your communication channel is secure, that's considered to be a pretty enough solution right now. So how it looks at the very low level. Don't get me wrong, you're not going to implement it, but I want you to understand how it looks on the low level. It's protocol specification in the version 3.1, one before. I want to tell you that the header is only 2 bytes. Now compare the header into the HTTP, which was 24 plus 8 plus 8 plus 31. Yeah, that's like a really small one. So in the first byte, you get just an information about the message type. And the message type list is here. It's just one of the 16. Not all of them are used. But they're like a 4 bytes, so 16 combinations bring you the message type. The next bit is a duplicate flag. Then there is a quality of service level. And the question if you should retain the message. And the next byte is just the length. So here, if the length is like an 8 bytes, it means that the payload can be up to 256 bytes only. So the message is total 258. And the maximum size. Of course, it's dynamically changed. So if you provide it for example, 10 bytes, so it's going to be 12 altogether. 2 of the header plus 10 of the payload. So that's scalable. So as you see, MQTT is not definitely for streaming. It's for exposing a state, just for sending the just for sending some very small parts of the information, like for example the temperature, the humidity, the angle, some measurements, or just to send you a request to rotate the servo to some particular angle, or just do that step by your step mode or whatever. But definitely not to transmit the video. Right now, there's a number of the messages. If you go through it, so when you connect, you send one message. So you send a request to connect, and the client name is a payload then. You can receive a connection acknowledgement from the broker. So you see like a double communication forward and back. The most common is to publish message or to subscribe to some particular message, like on here. So it's 3 and 8. But there's many more. You can unsubscribe from some particular message, so you don't necessarily need to break the connection to unsubscribe. You can dynamically subscribe and unsubscribe for what you're interested in. And you can also call disconnect. You should call disconnect the legal way, because if you just shut down your software or just break the connection, then that's going to arise this MQTT wheel. So here is a short comparison between the MQTT and the HTTP. First, MQTT is data-centric, right? Whereas HTTP is document-centric. So HTTP is considered as a protocol for sending a documents, which was mostly the HTML, right? Of course, it can be like image also or whatever. The pattern here is public subscribe, which somehow mimics the request response in HTTP, but that keeps the connection active, right? And here, this connection is like you send the request, then you break it, and then you get the response, and that's gone. Here, it's going to be on the TCP, so you publish, and then you keep it running, and so subscribe and keep it running. Now, complexity is really simple. Message size is small comparing to HTTP. It has 3 quality of service settings, and interestingly, library for MQTT written in C, in low-level C, it's about 30 kilobytes. In Java, it's 100. Now, consider how huge is Microsoft XML parser. I guess it's something like 100 megabytes, while the engine itself is a couple of the 10 or 20 megabytes. So it's really huge, right? I mean, HTTP is really not lightweight one. Now, the data distribution is here any you wish. 1 to 0, 1 to 1, 1 to n, and subscribe is both other way. So it means that virtually you can create a network which is n to m devices, when n is number of senders, m is number of subscribers. And you can have an unlimited number of connections and subscribes here. It's limited only by the resources of the broker. While in case of the HTTP is 1-to-1. You send a request, you get a response. So, a couple of the scenarios. For example, a healthcare. Imagine there is a patient that had a surgery, and when the person is home, just to prevent the crisis and detect early signs of something is gonna bad to happen with his or her health, you can monitor it using MQTT wheel. I mean, you can monitor it actively, but there should be an MQTT wheel saying, for example, the monitoring device is down, because that's a life-critical system. So in that case, you may quickly send the medical staff to, or the service just to switch on back the device to make it working, right? Drawbacks, as I said, security is not like a very sophisticated one. Pretty enough, but not very sophisticated one. If you use a protocol encapsulation over some secure layer, that's suitable. Now, MQTT uses the TCP, so this is the biggest drawback in terms of the IoT devices, of the IoT networks, because that requires an instant connection between the publisher and the subscriber. Well, don't get me wrong. You have here like a retaining of the messages. You have a MQTT wheel, so you can like connect on temporary, then you can switch back off. and you can do this asynchronously with any scenario, like a publisher and a subscriber. But still, when you publish something, you need to open channel and keep it running. It's much more energy demanding than just sending a datagram, like for example an SMS or the UDP over the 6LoWPAN network. So this is generally those two drawbacks I can find here. Protocol is simple. There is a number of parsers, so you can find the parsers almost everywhere in any language. And there is a parser pretty good called PubSub client for Arduinos and the ESP are gonna use on the in the laboratory environment. So MQTT is here working during your labs, so you are going to use it extensively. Now, if we revert back into this previous lecture, like last week, perhaps you can remember that I was showing you this regular ISO OSI stack with an examples of protocols you can use. That's here on the left-hand side again. And the layers on the right-hand side is like in case of the pure IoT stack. So it could be, for example, like 2.4 gigahertz communication for 802.15.4. I mean, like a Zigbee, Z-Wave, or any other protocol. It could be Bluetooth. 6LoWPAN for the networking layer, and here it's an UDP datagram, not TCP, but the UDP. It's for the low bandwidth, high latency networks. So over it, on the top of that, there's another protocol called COAP, Constrained Application Protocol in short. The COAP is again based on the HTTP. But that's optimized for the low constraint devices, like most of the end node devices in the IoT world. But it uses a UDP network instead of TCP network. Again, it's just to expose state. It's definitely not for streaming, right? So it's just for showing some essential information in the very short way. For example, send something to the display, get your temperature, get your air pressure from your meteo station or whatever. So COAP comes from the REST protocol. This representation state transfer protocol, it's pretty common right now in something we call microservices. You used to implement it, however, in case of the adult software and the PC used to implement using huge servers, like for example, Internet Information Services from Microsoft or Apache for Linux servers, the most two popular in the world, I guess. I cannot recall the server name for Java right now. Yeah, calling all Java developers. And here, any of you? Not really. Okay, so anyway, it doesn't really matter so much. But in case of the IoT devices, you cannot just put a whole server into this device. That's going to be huge and consume a lot of energy. So there's simpler implementation. And the COAP is really a REST service for the small devices. So what we have here is the same like we have in case of the HTTP. There are 4 methods. I just wonder if you know it, but they are really implemented. So whenever you use something like, for example, the address I'm using right now, I will share it with you on the chat. So that means that this part is an HTTPS and there is an address, but at some moment of time you get here a question mark, right? And you have a launch app equals true, which means that I'm using a get method. A get method is like sending some parameters over the URL request. Similar way, you can post, and the post happens whenever you submit a form on the web. You have a form on the page, and then you have a submit button, and perhaps under the hood you will see in the HTML something like a form method equals post. So that means that when you click the button, this data is collected from this form, and it's sent parallel to your HTTP request like a post method. But there are two more, which are not very common in case of the HTML and the HTTP. That's put and that's delete. So like four of them. Get is to get something, put is to put something, post is to post something, and delete is to delete something. That's implemented in REST, that's implemented in the HTTP, and that's implemented in the CoAP. Same principles. Now, there's an RFC, of course. It is a resource-oriented protocol, not the document-oriented protocol. So we will just have a simple payload then, not a very structured one. But still, you can think about it like you can put there, for example, a JSON structure. Now, because it is designed for the slow networks, it has really limited packet size. They assume that a high degree of packet loss and that periodically the devices can go offline, like, for example, to sleep. So how it works is following. Every single resource is right now offered over through your device. So your device is like a server then. It is somehow opposite than it was in case of the MQTT, right? In MQTT, you were emitting and you were connecting to some broker externally. Here, it's opposite. Every single device is a server, and the device can talk like a mesh network way, one to another. So on this application level, control is like a pure mesh-to-mesh communication. For example, the sensor can ask actuator to open the window, right, directly because it's too hot inside. Or the ventilation can switch on, or the solar panel can inform the kettle to start boiling water because it's enough of the solar power at the top. So this is the way it works, right? They do not connect over the central point. That's good because there is no central point you can break. That's bad because you need to provide services yourself on every single device. So it's a little bit more demanding than MQTT client. Now, every single resource, every single device requires to have an address. This address is called host. You can think about this like a website name. Yep. Similar way to the HTTP is like you simply type COAP. There's a version with S, COAPS, like an HTTPS and a COAPS. Then two slashes, column two slashes, host, and then you can have a port name. So again, it's like in case of the TCP and the UDP, you have a 65536 port starting from 0 till 2 to the power of 16 minus 1. And then you have a path. After that, there comes a query after the question mark. This query is for the get. So if you now consider it, the link I have sent to you, anyone actually in the web, it's like one-to-one, but instead of HTTPS, you can put COAPS or COAP for non-secure connections. So virtually, it supports any content type. So as over HTTP, you can download or access any content type, virtually any content type that your server can host. It's same here with the COAP, so it's not limited. But definitely, there are some of the standard content types that are already predefined over the standardization. So, for example, some of them are like text plain, or the application and some link, or XML, or the octet stream. Octet stream is an encoded binary stream, something like called base 64. This is the way to represent the textual way, the binary data, and many other, including JSON. So this kind of the approach, it easily integrates with the existing web, right? You just change the protocol, perhaps over some protocol translator, which could be, for example, the Node-RED for you, if you're interested in that works this way. It's a protocol converter. So I'm just trying to tell you that I can virtually find any content you wish here. Again, theoretically, you can put in the COAP, for example, an MPEG movie, but there is really no reason to do that, right? So I can have an application / JPEG or image / or video / MPEG, whatever it is, it still works here. Now, the resource is identified by the IP, or eventually, if you have a name resolution, it's by the name, same like in the web. But here it goes over UDP. So It means that the messages between the request and the response, they can be exchanged asynchronously. There comes a request, there comes a response, but if it is in chunks, the UDP network principle says there is no assurance in ordered delivery. So it means that, for example, part number 2 can come first, and then can come part number 1. You need to be ready for that, and you need to have a mechanism that is able to trace the requests and the responses and make their identification. So there's always kind of the unique ID between the request and the response that is telling you which request is related to which response and how it works. But first of all, the messages that you transmit over the COAP can have a following form. Confirmable, which is marked like a con request, and that requires an acknowledgement. Non means non-confirmable, which doesn't require acknowledgement. So, for example, I ask for something, but I'm not expecting to have an answer. It's exactly like me right now asking you a dummy question and no one answers of the students, which is pretty common. Now, ASIC acknowledge is just a message itself. The reset. Reset is kind of the message when the receiver is in doubt what exactly the sender means. For example, it can happen that one of the messages constituting the request or the response was gone due to the network congestion or network down, and suddenly you get a message that is like a part of, you have no idea what is that. So then you send a reset and you ask the second endpoint to start the transmission from scratch again, for example, to retransmit all the information you expect to have, whether it's a request or a response. You can use it like a ping message also, like if an empty reset message is a ping message in this case. Empty is just like a 4-byte header only, nothing special, just send an empty message dummy, but no one is doing that because there is no reason to do that. So the transfer is non-reliable. So it means that the messages can appear duplicated. So you can have it like a twice. They can disappear without no notice, or can be delivered unordered, like I previously mentioned. So because of that, there is a very simple reliability mechanism implemented in the following features. It is actually 2 of them. First, if you cannot have an acknowledgement, then you may assume that the second endpoint didn't get a request, so just retransmit it. This retransmission is like a stop and wait. So you wait and then you retransmit, and you make an exponential backoff, which means the time between the retransmission changes. That means that, for example, there is a network congestion, like a peaks in the network communications. You can avoid them by using this exponential backoff. This exponential backoff is sometimes modified by the random number, just to change, not to all the devices, for example, send the data in the same moment of time, and they repeat in the same moment of time because they follow the same exponential backoff. Of course, it applies to the confirmable messages. If it is non-confirmable, no one cares. Now, the second mechanism is duplicate detection of the con and non-messages, which comes by the unique identifier. And I didn't mention it yet, but when we just got back here, 2 slides, it's information that COAP can go through proxy, and it can be cached. It's same like with the HTTP. So you can make like a proxy to provide a kind of the cache. For example, do not wake a sensor network, but just to get the latest data. I'm going to return to it in a minute, so we'll explain it more. Now let's follow the scenarios. So on the left-hand side, you have a first request. Please mind here it's stated token. Its token is 0x70 hexadecimal. And it's a unique token for the request response. In this scenario, the one on the left, the situation is as follows. A client asks, for example, for the temperature, right? So it says, okay, get temperature. Please give me the temperature. So you send you issue the URI COAP / some IP address / maybe some port if necessary / temperature, and you are asking for the temperature. So you send a COAP request saying, okay, token is 0x70, and please give me the temperature. Now, there are two possibilities. The server, which is the IoT sensor device, perhaps in this case, it can have an answer ready because it's measuring all the time, right? This is the scenario on the right-hand side. So here you send an acknowledge with payload included. However, it can be also the situation when you just wake up the client and the client said, okay, I need to make a measurement, but it will take some time. For example, to stabilize the gas sensor, to make measurements of the air quality regarding the different gases that are in your room, most of the sensors, they require something like between 30 and 45 minutes to stabilize. So you send, you get a request and you send, okay, get your request, but you need to wait for the data, right? So you send first acknowledge, and then you send a con message saying, okay, here's your data. Look, it's all binded by the same token, right? So we send, okay, 0x70, here's your data. Please acknowledge, because the type of the message was con. And then client says, okay, gas the temperature, thank you. And that's all the transaction, right? If your data is ready, like out of the box, you can make an acknowledgement with the payload, just all in once, and you send just the single message. So there are like two possible scenarios, right? Now, here is another situation when you ask someone for the data or for a service that it cannot deliver. For example, you request the server for non-existing service. Like, please give me a temperature. And this guy is saying, dude, I'm here for monitor the soil humidity. I have no idea what is the temperature. So you just provided, well, no surprise, something pretty common in HTML is 404 page not found, isn't it? So here it's similar, 4.04 not found. And you respond with the same token just to be absolutely sure you can bind the request and the response with some other unique token, right? The next one. Now, here is a situation when you get a non-confirmable. So the client sends a request for the temperature and saying, could you please get me the temperature? But actually, I don't care whether you will do that or not. And the server then says, yeah, here you are, but I also don't care if you get it or not, right? So it's like a non this way request and non this way with the response. Yeah? So this is how it works. Now, the configuration of the protocol itself, or the service actually, and the clients, it has a couple of features. First, acknowledgement timeout can be like, for example, 2 seconds, but for the networks that are based on the GSM and you use SMS for sending a message, I would give here like 2 minutes or even more, isn't it? Now, this random factor I was mentioning here, it's like randomly changing this number of time that is the amount of time that is between the retransmissions. Again, number of retransmissions can be also specified. For example, you retransmit the data, but no more than just a couple of, or a request no more than just a couple of numbers of times. So that should be like a reasonable limit here. Those are the default configurations for the clients. So that's something you can change in your configurations later on. Now, if the collision occurs, the retransmission is done at the growing intervals until success, right? So that's it. Yeah, if in terms of repeating, like in case of the Wi-Fi communication, pretty similar algorithm. Now, there is an extension to this protocol, and we call it options. And they can be both for the request and the response. These options can specify something that is related, for example, for a proxy. If you keep something in proxy, then it's essential to provide its maximum time it can be kept there until it becomes invalid. For example, if you measure a temperature and you measure it once an hour, perhaps its max age H time is just a 1 hour. After 1 hour, the broker shouldn't keep this data because that's out of date. Yeah, that's invalid already. So it's outdated. And there's a number of options stated in this protocol specification. But what is important here is just to know that there are two classes of the options. The first is critical, and the second is elective. Let's start from the elective. If someone makes a request to you as a server, and there's an option that is on the elective list, and you have no idea what is this option actually for, so you don't recognize it, then you can ignore it. If this option is on the critical, then you should answer, even if you can recognize the request, that you should answer bad option. It's a special error for that. It's 4.02. Maybe it has happened to you on the web sometimes. You get a bad request from the domain name services when the DNS is down, or you cannot make a recognition, then you have a bad request. So here it's pretty similar, right? So if the option is critical and you don't recognize it, you don't process the request. You just reject the request saying 4.02 bad option. Whether it's critical or not, it is specified by the RFC. Now, if the option appears in the response and is unrecognized, then do you reject this response? So, for example, you have a con message from the server, confirmable, and you get this confirmable, but there is an option you cannot recognize, then you don't send an acknowledgement that you get it. Options can be also classified regarding if they are safe to cache or forward. So maybe sometimes you want to remove it, for example, because of the security reason, you don't want to put some options. Now, COAP can be proxied and reverse proxied. So the disadvantage of the COAP is here that the client, someone that sends a request, needs to have an access to the server, which is an IoT device. And this IoT device could be, in this case, in your NAT network, behind the NAT or behind the firewall. So you cannot access it then. So you need to make an appropriate firewall rules. This is the hell of the HTTP actually working the other way, right? It's easy to access from your personal computer at home the public servers, but it's not so easy to make it opposite. So the same applies, the same considerations applies here for proxying, right? When you go through the proxy. Now, like in HTTP, there is 4 methods for resources. So first, GET. Well, here it's more like it comes from the REST protocol. So HTTP is not implementing all of them. I mean, it can, but it's really not implementing all of them. So first is a GET. So you request an information for some resource. The second is POST. So you want someone, the one you send the request to, using POST, to process some data. For example, the POST could be a service that is encrypting or decoding something for you, like, for example, converting some data of one kind to another, or encrypting service that's located in your network to let you encrypt the data before you submit it somewhere else. Put is pretty similar to POST. Now, delete is usually a request to delete a resource. So, for example, well, COAP is stateless protocol, so you don't have a state, you don't keep the state. It's different than in case of MQTT, which is stateful. COAP is stateless, but sometimes you can, for example, keep an identifier like a cookie to identify your client in the longer scenario. So, for example, delete would be good just to tell the server to delete this session for you. Client can also send a discovery multicast to discover nearby services. I'm not sure how is it in your case, so let me unmute you and ask you for one thing, guys. Do you have any experience in programming in Microsoft technologies? I'm particularly asking about the Windows Communication Foundation. Any one of you, or is it like in your courses in RTU?
Not really. Oh.
Not really. Okay, so just let me explain you the way it works from scratch. As you have a number of the services, then the problem rises how to find what you can have. From the human point of view, we mostly use Google, right? So we just Google for something, and there's like a catalog of the services you can have, a catalog of the web pages. While in this synthetic world, Microsoft has invented something we call WSDL. I'm just wonder if you will be able to see it. Let me try to access it. Please give me 1 second. I will see whether it works and whether I can access it or not at the moment. Some time ago, I implemented a kind of the tier of logic circuit simulator. And that's written just in the, yeah. Okay, I will change the screen sharing for a short moment of time. Just please hold on. Oh, no, not this one. And return back to sharing another browser with you. Okay, it's empty at the moment, but yep. Okay then, so what you can see right now is something that has been automatically, just first of all, would you please acknowledge that you can see the service web page with a number of XML?
Yes.
Okay, so what I'm just trying to tell you is there's a way to describe the services. And one of this method is just something we call WSDL. So Windows Communication Foundation is communication standardization between the endpoints for the Microsoft technologies. Here you have a description, for example, how to send a request. So when you send the request, you get some metadata you need to. It's for HTTP, so actually it's for WSDL. So you provide something we called an XML, and then you can make a particular request to the service, and then you know that the data is well structured, right? You can even have a kind of the validator for the XML here. And it is a very same for the COAP. And the COAP has a kind of the discovery service. And this discovery service can help you to just let me switch back to our presentation. Yeah. So COAP has a way to expose all the services around you and what you can have. It's kind of the advertising, let's call it this way, right? So it advertises that. So it goes over some particular standard port called 5683. You cannot use this port for any other services. And 5684 if you use secure communication. You can send a request using COAP, and you will instantly have something we called core link format response. And this is really great because on this application-level protocol, when there comes a new device into the IoT network, that it can detect itself the environment around it. For example, it can detect the actuators, it can detect some other robots, it can detect some other services that it can be offered. That's all you can have here, like automated discovery and automated machine-to-machine communication. So this is like a really IoT principle where the devices can find themselves without pre-configuration. For example, you not necessarily need to provide a configuration for the particular URIs for COAP. It can be done itself. based, for example, on the content, right? Okay, so the summary for the lecture today, it's like assuming that you use some higher standardized protocol like an MQTT or COAP. Actually, as you see, no one knows that you're a dishwasher, right? For example. Yep. Internet can save its device's identity from exposing, so you can play and be virtually anyone there, right? And know it well, as you do. But that works both sides. You can be fooled or you can fool someone. That's about the IoT security, but that's going to be like a next lecture. I'm just going to share with you in the 1 week time from now. Now let me get back into the situation we have. So I will switch back you on to voice because I want to discuss something with you. First of all, I would like to ask you if all of you are already subscribed to our online lecture, as I was already asking you to do. If you don't, I will make a list available for you to type your email address and first and the last name, because I will need to provide an account for you for this online course that is actually running on the Moodle platform at our university. So, I mean, our university means here in Gliwice, where I'm right now. So I will ask you to join there for this course. I had open 1x, as I announced at the very beginning of these lectures. Those who are already studying there, just keep going and go through the quizzes and go to the end. Next, we today agreed with Agris that instead of using this hardware that was actually purchased to you because of the situation that you cannot access the university nor the physical labs, we will switch into the virtual labs. So I'm going to make a short show for you right now online, just to let you see more or less how it works. I will provide a section with labs till the weekend. So you will individually go through the laboratory tasks. I think there will be about 5 of them. And I will ask you to provide a report for every single task. You will work individually. The online laboratory works through the web browser. So all you need is like just a web browser. I suggest you to use Firefox, eventually Google Chrome. Do not advise you to use the Microsoft ones because they used to break the layout. Particularly the Edge has some problems. So I will just try to share screen with you again. Okay, it's empty now, and let's go for this. The links will be provided to you, so do not worry. So we go, and you will need to make a registration for you. So you click login, and under the hood, there's a register. And if you go to the register, you just generally type your username of your wish, your real name. Please provide your real name to let me identify you. It's an external system, because that system runs actually in Tallinn Technical University. Your email address, you may use any you wish, but it must be a real one, because otherwise you don't have your password. The system works the way that the password is created for you and it will be emailed to you. And now, organization. Just go into the Silesian University of Technology. Super simply, but go to the Silesian University of Technology. Once you register, you will be able to log in. So you just get back here. That's my user and password here. I log in, and what I need to do is just I need to book the device. You book a device exclusively, so please do not book it for longer than necessary. Let's keep it like 30 minutes for a single lab, or 40 minutes, okay? So you go to the distance lab, devices, and then you scroll down, into this section here. I'm preparing a couple of new nodes for you just to experiment with, but generally you will focus on the nodes 1, 2, 3, 4, and then 8, 9, and there comes 10. That will be also provided to you over orders, so it's not very important. If you click there, you'll have an ability to book a device. So you need to see whether booking is available. As you see, some students are working here because you share this device with virtually whole the world. You book some, for example, like today, and now I have this lab, so I can like click it, and there comes a new user interface. And this interface is like you see the stream from the camera, and then you just create a new file. So you just type something like Arduino-based code, like we use. The controllers here are ESP8266. There's not a controllers ESP32, this previous generation, but still you have like a separated Wi-Fi network you can connect to. And this Wi-Fi network is also equipped with the MQTT broker that you can bind your device, which is in this private network, with the external board. Now, what is the trick is, you can connect to this MQTT broker even from outside, from home. So, for example, you can have this MQTT Explorer on your computer, and you can connect to the same broker on the public address, because that's available on the public and on the private addresses both. Like you can have it from outside or from inside using those devices that they are here. So for example, I will go into some predefined user file, like for example, mine could be this one. It's pretty simple. You click compile. You should have an information that it's okay, and then you click upload. And now it takes a while because it needs to prepare a package and inject it from Estonia to Poland, so it goes over internet. Fancy solution when you compile a code in Tallinn and you flash it in Gliwice here, but we are using this from Riga, right? As you see, James Bond here, London, hello IoT as stated, so that this is the way it works. So we will write, generally, you will write all your software here in this section. Now, there is a ready laboratory instruction that describes every single node step by step, and also hand-on labs with the scenarios. So I think you will handle that with ease. I will provide you a description of which tasks I want you to implement, and that will be also stated which devices you can use, because that's related. They are not homogeneous; they are heterogeneous. So some of them look like that. Some of them look totally different way, like for example this way. Oh, sorry, one more zero. For example, this is the robotic arm you may use as well. And some of them are even located outdoors. You see? So I believe you will have a lot of fun with those. So the description will come in the laboratory section in the Ortus. One more thing, your project. In the Ortus, that waits a project section for you, and you can start to think about that already. I wrote description what I want you to do, and there is also a forum waiting for you there, so you can like make a questions in case you have any ideas. This project is more like designing an IoT solution. It's not like implementing the real hardware. It's more like designers work. Okay, so it's simplified here. You don't need to solder anything. You don't need to implement, write this line of code, but instead you are supposed to make a kind of the business solution. Yeah, the deadline is here. Just let me see. Yeah, as due date is 20 May. So I want you by this to submit your project proposal. So I will evaluate it later. It should be just in the form of the PDF. A good starting point is there's a template, downloadable template, editable, and also as a PDF. So you can like start from downloading this template and starting to extend it. There can be really various scenarios. You can think about like smart home, smart agriculture, for example, maybe some poultry farm. It could be also like a traffic light solution for the city or for the highway. It could be like well, maybe traffic light is not highway related. It can be like healthcare management system or whatever you wish. It's really up to you. It's pretty open for the ideas here, just for your imagination. That's how it's gonna work here. And now one more thing. I was talking to Agris today as well, and we decided that the test. I was actually hoping to have you the following week in Riga. The test will be in May and will be prepared for you asynchronously in the Ortus as a form of a quiz. Yeah, there's a question where to send it. I will prepare a resource for you in the lecture session, so that will be open for you just to put your names there. So please be patient. I will try to organize it this week. Okay, guys. So it seems we are good. I hope everyone is healthy. Keep safe. Stay at home if possible. I think it's gonna be over soon, hopefully. So maybe we'll have an opportunity to meet maybe next year or next academic year in fall when I come to Riga or maybe some other day. But right now, virtual communication.
Thank you.
Thank you so much, and enjoy your afternoon. Hope you have a beautiful weather as it is here.
It's really windy out.
Yes, it is here as well, but we have this kind of the Dubai style. I mean, it's not so warm, of course. It's pretty cold, but blue sky finally, and we are grounded. Doesn't help.
Yeah. Thank you. Bye.
Thank you. Bye-bye.
Bye. Bye.